Assalamualaikum warahmatullahi wabarakatuh dan selamat malam saya ucapkan kepada Miss Laili dan rakan-rakan yang saya kasihi sekalian. Jadi pada hari ini, saya Muhammad NURHAKIMIN bin MANHAIRI dari kelas INCHEON akan membentangkan pembentangan fizik saya yang bertajuk Total Internal Reflection. So, let's go. Refraction of light. Okay, so refraction of light ni adalah salah satu properties of light yang mana saya rasa agak penting untuk kita sentuh pada topik hari ini because dia ada kaitan lah dengan total internal reflection. Actually ada banyak lagi properties of light, but I think it's a bit unnecessary for us to touch on that. Okay, so refraction of light. Refraction of light occurs due to light travelling through different medium with different optical density. That causes change in velocity of light. Okay, so basically apa dia nak cakap is light ni kadang-kadang boleh je pass through object, let's say macam kaca, but dekat situlah turning point dia. Light ni velocity dia akan berubah yang mana akan menyebabkan light tu akan bend from dia punya jalan yang sepatutnya lah. Also, note that optical density is not the same as density, because okay, let's say oil and water, let's compare both of them. Oil is less dense than water, but kalau kita cakap optical density, oil is optically denser than water. That's how it is. Also, this is a bit, ada satu FYI dekat atas ni, speed of light is around 299,792,458 meter per second. But biasanya kita tak pakai pun exact number dia because selalunya kita just round up to 300 million meter per second. Okay, so ni lagi sikit FYI, formula involving refractive index N. Okay, so first one kita ada N equals to C over V, yang mana C ni stands for speed of light in vacuum and V ni stands for speed of light in that particular object yang kita tengah cari lah, dia punya refractive index tu. Moving on to the next one. This one kita apply daripada Snell's law. N1 sin I equals to N2 sin R. Okay, so N1 sin I ni kita ambil daripada refractive index yang pertama tu, and dia punya angle to the normal equals to refractive index objek yang kedua tu and angle dia juga ke normal. Okay, the third formula kita ada N equals to real depth over apparent depth. Okay, ni biasanya kita apply dalam pengiraan berkaitan dengan kolam lah. Biasanya kita akan kira macam kedalaman ikan tu. Yeah. Okay, so actually dia senang je nak tahu bila korang salah kira N ni, because N is always bigger than 1. I mean N is always greater than 1. Okay, so dah habis dengan kita punya basics of total internal refraction. Now is the real part. Kita akan belajar about total internal refraction. Definition of total internal refraction: complete refraction of light ray reaching an interface with a less dense medium when the angle of incidence exceed the critical angle. So basically apa dia nak cakap is when light ray move from object with higher optical density to lower optical density, bila dia exceed a certain angle to the normal, let's say the angle is 45, bila dia lebih daripada 45 tu, dia akan completely reflect. Light tu akan completely reflect macam dalam gambar ni, diagram ni. So dia akan jadi macam cermin lah, something like that. So what exactly is critical angle? So tadi korang mesti tertanya kan, apakah itu critical angle? So basically critical angle is the angle of incidence beyond which ray of light passing through a denser medium to the surface of a less dense medium are no longer refracted but totally refracted. So apa dia nak cakap dekat sini is critical angle ni adalah is a minimum angle yang mana bila kita lebih daripada angle ni, light will no longer refract but rather light is reflected, like completely reflected. So untuk total internal refraction, kita kena tahu 3 cases ni lah, yang mana I less than C, I equals to C, or I greater than C. So let's get. Okay, so for the first case, incident angle less than critical angle. Okay, so ni just normal case lah sebab dia apply Snell's law lagi, since Incident angle ada, pop refract sini. Yeah, it's basically it just applies Snell's law lah in calculation pun. But you see, bila kita gerak from denser medium, dia akan ada reflected ray. But untuk the first case, the ray is very weak lah, so you can barely see it. So for the second case, incident angle equals to critical angle. So dekat sini kita boleh nampak R kita equals to 90 degrees. So kita boleh cakap kita punya refracted ray ni is perpendicular to the normal line. Lepas tu stronger reflected ray. Reflected ray kita pun ada, but yeah, stronger than the first case. So for the last case, atau kita boleh cakap main character of the day, is incident angle greater than critical angle. Okay, so dekat sini kita boleh nampak there is no refracted light ray at all. So kita boleh cakap yang the light is completely reflected. Inilah special dia. So dekat sini pun katanya incident angle sama dengan reflected angle. Okay, so dekat sini kita ada for your information lagi formula yang berkaitan dengan critical angle lah. Okay, so dekat sini kita boleh kira refractive index N equals to 1 over sin C. Okay, so bila kita dah ada formula yang kaitkan dua tu, refractive index and critical angle, dari situlah kita boleh buat relationship bahawa when refractive index increase, critical angle decrease, or kita boleh cakap refractive index is inversely proportional to critical angle. Okay, so another FYI, refractive index table. Okay, so ni some of the most used material lah. Macam korang boleh tengok, ice, glass, diamond, water. Boleh baca lah. Vacuum is the lowest lah, definitely. Here are some of the most common applications of total internal reflection in daily life. So one of the application of total internal reflection is that it is applied in the making of optical fiber. Okay, so I think it is commonly used in engineering field now, since it is much more efficient than normal cables because it transmit light instead of electric signal. Okay, so how does optical fiber works? Okay, so inner core have higher refractive index than outer cladding. Okay, so basically dalam dia ada higher refractive index than luar dia, than the cladding luar dia, that makes total internal reflection occurs repetitively throughout the cable lah. So yeah, it transmit light faster compared to when using normal cables that uses electricity. Okay, so another application of total internal reflection is the cat's eyes reflector. Okay, so kalau korang tengah jalan-jalan, tengah drive tu, tiba-tiba korang tak nampak apa-apa daripada jauh, but suddenly bila korang datang dekat, korang suddenly nampak lampu atas jalan tu. That is most likely cat's eyes reflector. Okay, so apakah working principle benda ni? Light from the headlight of the car direct towards the cat's eyes reflector and experience total internal reflection at the back of the light. Light is reflected back to the eye of the driver. Okay, so apa nak cakap is lampu yang daripada kereta korang tu masuk dalam benda ni and experience total internal reflection and dia reflect balik dekat mata driver. Okay, sebab tu lah korang nampak benda tu bersinar. Kalau tak, so maksudnya kalau tak ada lampu, tak adalah benda tu bersinar. Okay, so that's why benda ni efficient since dia tak guna elektrik. Kalau kita nak compare dengan guna lampu jalan yang pakai elektrik tu. That's all from me, Muhammad NURHAKIMIN bin MANHAIRI. I hope you guys enjoy the video. Thank you.